Periodic behavior is a behavior of a function that repeats its values in regular intervals or periods. When an object is in simple harmonic motion, is when its acceleration is directly proportional to its displacement, and acceleration is always directed toward the equilibrium position. The equation for an object to be in simple harmonic motion is y equals a sine omega t, or y equals a cosine omega t. Define the concepts and formulas for amplitude, period, and frequency. Amplitude, universal value of a, is the maximum displacement of the object, usually measured in inches. Period, 2 pi over omega, is the time required to complete one cycle, usually measured in seconds. Frequency, omega over 2 pi, is the number of cycles per unit of time, usually measured in hertz. 3 examples of a simple harmonic motion are a pendulum, a swing, or a vibrating spring. Damped harmonic motion is simple harmonic motion in which the amplitude is governed by the function at equals to ke to the power of minus ct. So in this way, the amplitude might be increasing or decreasing. Its equations are y equal ke to the power of minus ct sine omega t, or y equals to ke to the power of minus ct cosine omega t, where c is a damping constant and is greater than 0. K is the initial amplitude and 2 pi over omega is the period.
Number 30. The graph shows the variation of the water level relative to mean sea level in Commonsent Bay at Tacoma, Washington, for a particular 24-hour period. Assuming that this variation is modeled by simple harmonic motion, find an equation of the form y is equal to amplitude sine of omega t that describes the variation in water level as a function of the number of hours after midnight. After observing the graph, we can define that the simplest way to achieve the function is through a negative sign. We observe various details from the graph, such as an amplitude of 6, a period of 12, and the period of a normal sine graph is represented as 2 pi over k. Using this information, we now know that the amplitude will multiply the entirety of the sine function. The initial point is still 0, so there will not be a horizontal shift, and the vertical shift, and no vertical shift because the equilibrium point stays as 0. Knowing that the period of the graph is also considered as omega, we divide 2 pi over 12, thus giving us the total period to complete one cycle. Therefore, the final equation is y equal to minus 6 sine of p over 6 t of time.
A Ferris wheel has a radius of 10 meters, and the bottom of the wheel passes 1 meter above the ground. If the Ferris wheel makes one complete revolution every 20 seconds, find an equation that gives the height above the ground of a person on the Ferris wheel as a function of time. First, you must decide what kind of function will fit the height change. It could be either sine or cosine because they are both regular and cyclical. After finishing that, you have to find the amplitude change. Normal amplitude for the sine functions is 1. You are looking for amplitude of 20. Therefore, the unit W must be 10. The next thing to consider is that the middle point of the Ferris wheel is 11 meters high. This means the vertical shift will be 11. After finding the vertical shift, you must find the horizontal shift. While this step isn't necessary as the graph is mathematically sound, this step is important to make the graph have real-world applications. Without this step, the person would start as if he were already at the middle of the ride. To account for this, we have to shift the graph 5 units, to the left or to the right. The final step is to figure out is the period. Knowing that each revolution takes 20 seconds to complete, you can see each period has to be 20 in order to show that the change in height has gone back to the initial position. You have to convert the initial period of a sine function, which is 2 pi, into 20. First step is to cancel the pi. You must then find the quotient of 20. The answer is 10. Thus, the change to the period is the fraction pi over 10.
Wee! I'm the king of the world! Wee!